Good morning. Today we're going to do something called Doodle Notes. And here's some scientific knowledge of why it helps. So using both sides of your brain at once while you learn this to help you retain it better. And look at all these cool things. It gives you energy, alertness, engagement, retention, memory, problem solving. Look at all those fun things. So here we go. So these are our Doodle Notes for today. So we're going to do a little doodling. And you can color in the numbers. I'm going to go through the basic notes, and you can add in extra doodle stuff as we go. So basically, this number, 2,540,000, is a big number. There are so many digits. Sometimes with numbers this large or small, this large specifically, it can help to rewrite them without the extra zeros, which is what we're learning today. It's called scientific notation. So we have numbers like this that are huge numbers. So let's write that here. I'll pick green. You can pick whatever you want. So these are huge numbers. Oh, I'm going to write it with a thicker marker. Why? Because I can. Huge. Look, I'm doodling already. And then over here, we have this number like 0.008264. That is not the mathematical way to say it, but that's how I'm going to say it today. So then you have really huge numbers and you really, really, really tiny numbers. Tiny. Okay, I probably should have picked a darker color, but hey, look how tiny that is. Oh, that's why I did it. 0.1 thickness. Okay, that might be too thin. Well, so we keep the first non-zero digit. That is key. We keep the first non-zero digit. So in this huge number, that would be the 2 is what we keep, and we put a decimal right after it. Over here, the first non-zero digit is not this 0, not this 0, not this 0. It would be our 8, and then we'd put a decimal right after it. Place a decimal point. Decimal point before the next number. So it'd be like here, we put it here. And here we'd put it in this comma spot. Cool. And use the power of 10. 10 has some power. We use base 10 on certain things as we go through to correctly represent how we move the decimal point. So technically here, we're going to divide. And we're counting up how many decimal places. So this would be 1 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s. So this would be times 10 to the 6th power. This would be 1, 2, 3. That would be negative because it's a tiny number. So it would be a negative 3 times 10 to the negative third. Now, what am I talking about? What's going to happen? Well, let's look at the rewritten format. It's called scientific notation. Yeah, you can color that in. Woo! That's what I'm doing right now. That's it. Okay, so you color. I'm moving on for the math. So let's look at these numbers and what they would become and look like. Oh, we kind of snuck to that answer up there. So for this one, we start over here to the right, and we can count up how many spaces we move till we get to that first non-zero number. So we move over 1, 2, 3, 4, 5, 6. We moved 6 spaces. So this becomes 2 point. See that decimal? Now we need the digits that are non-zero. So the 5 we're going to leave. We're going to leave the 4. We don't need the rest of the zeros. Times 10, and how many spaces did we move? 6, so it's to the 6th power. Okay, let's look at small ones. No, let's finish this. So when converting a number into scientific notation, if you're moving left, it's a positive. And I always think of it, the big numbers are the positive numbers, right? So that's why there's this big plus sign. Definitely color that in. Definitely get like a nice like color going on there. And like color it positive. That's a key one to color because we're looking at positive ones over here. So that exponent 6 was a positive exponent. So we're looking at a giant number. It's a big, huge number. Okay, so if you move the decimal to the left, it's going to be a positive power of 10. Cool. Now we're going to scooch over here before we get to the careful. Okay. So let's look at what this one would be. So this time we're going to start from our decimal, and we got to work our way to the left. Sorry, I said that wrong. It's early in the morning. Let me start over now that I have the right color. We're going to start at this decimal. I'm going to have the right marker. Okay, we're going to start from this decimal, and we're going to move it over to the right this time. We're not going left, we're moving it to the right because it's a tiny baby number. All right, so we're going to move it over a 1, 2. There's that non-zero number, so we stop right there. So this will be 8.264, still times 10. But since we're going that way and it's a small number, it's to the negative third power. The 3 came from how many we moved, and the negative came from the fact that we're moving to the right. I also like to think of it tiny number, negative, large number, positive. That helps my brain. So again, you're going to want to color that negative here, because if you move the decimal to the right, it's a negative power of 10. But again, I like to think of it as a small one, as a negative. Easy. Okay, so you're going to try that in just a moment. You can do that now. If you want, you can pause the video, try it, and check. I'm going to go through this careful right now. So careful. Moving the decimal point to the left represents dividing by a power of 10. Oh, I'm still not transparent, all right. Here we go. Okay, back to 1. Oh, you know what? Text box. Easy. Represents dividing by a power of 10. That's technically what we're doing. So we must write a times 10 to the power of that number when we put it back in there. And then moving the decimal point to the right technically represents multiply by a power of 10. The key to watch out for, now this could be a good doodle add-in. Watch out for, it's not really the number 4, but F-O-R. I'll shorten it up. Forwards and backwards. So moving forward and moving backward, moving right and moving left. Since we're doodling, I drew arrows. You could write words. That's fine. So hopefully you tried this. So if we move it, we're going 1, 2 to the right. So that would end up as 3.37 times 10. Since we moved to the right, and it's a tiny decimal number, it's a negative 2. Because we talked about it. In scientific notation, negatives are fine. When we did our exponent rules, negative exponents made it into a fraction. So this is just the decimal version. Ta-da! Okay, so here we go. So powers of 10. Here's how this is going to go. So if we had our powers of 10, 8 times 100. Okay, easy, right? You know that's 800. Okay. 5 divided by 100 would be 0 and 5 hundredths. 5 hundredths. Cool. And then we'd have 6/10 times 1,000, which would give us 600. And 9/10 divided by 1,000. Oh, excuse me. Is 0.0. A zero. 9 10,000ths. You have place here and then your thousandths here, so 10,000ths. Okay. So dividing by 100 is the same as multiplying by 10 to what power? Dividing by 100, so if we move it over 2, it's the same as multiplying 10 by what power? Negative 2. So let's do some practice here. So So we're going to think if we're multiplying or dividing, if we have a larger or smaller number. Shall we do the words first? Oh man, why is it sideways? Okay, so working backwards. When converting from scientific notation into standard form is like this, just the number, just the number, just the number. It's standard number. Okay. Remember that the decimal is moving in the opposite direction. So if the power is negative, you move to the left. Obviously, if it's negative, you move it so it looks more like a decimal. And if the power is positive, you move the decimal to the right to make it look like a giant number, a big, giant positive number. Okay, so we have that idea. We are good to go. So let's try it here. So standard form, we start from up here. We're going to move it 1, 2, 3, 4. So we moved it 4 to the positive, so that would be 5.679 times 10 to the 4th power. Now if we're moving it backwards, we're going back. See, it's a negative. They just said if it's a negative, you move it to the left. So moving it to the left 2 spaces here. I also like to think of it as I'm making it smaller because it's a negative up there, so it's like a decimal. So that way when we put that decimal here, don't forget your placeholder zeros, so it'd be 0.024. There's our standard number. 7,000. Start from over here, we go 1, 2, 3. Ooh, that would be 7 times 10 to the 3rd power. Now from here, this is 1.65 times 10, and there's nothing there. What is that secret exponent if it's not written? 1, because there's 110 right there. So only need to move it 1. We moved it to the right. Why? It's a positive number. We're making it bigger. So it's 16 and a half would be written as 1.65 times 10 to the first. Now this one's kind of a little ridiculous. That's kind of a normal. We wouldn't really rewrite 16 and a half as scientific notation. We use it for the really big numbers, the really small numbers. We can, but this seems like even more writing than this would be. So it's not so bad. Okay, next one. We only need to move that 1. Ooh, so again, we're going to have another 1, secret 1. Since it's a decimal, it's a small number, so we have 9.38. Now this 0 is important because that 6 is still there. We'll talk about significant figures where you really only need 3 decimal places to the right, but for now, this is fine. This is good. Times 10 to the negative 1. That's a negative 1. Let me make it more visible there. Don't make it look like 10 minus 1. That kind of looks like 10 minus 1. It's 10 to the negative 1 power. So watch out for that. And the final one. Ooh. 1 and 469 thousandths times 10 to the 8th power. Now that's a positive 8. We're going to make it a big number. So since it's positive, we're moving it to the right. 1, 2, 3, 4, 5, 6, 7, 8. A lot. So we have a 1, a 4, we have our 6, we have the 9. Now, I don't put commas yet. I make sure all my zeros are in place before I add in any commas because I'm not quite sure where they're going to go exactly yet. So I knew we moved it 1, 2, 3 here. We're going to need 5 more because 3 plus 5 is 8. We need 8 total. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, did it. Now I have a comma here, and there it is. Done. Okay, so there's our notes for today, and then it gets a little bit more complicated, so we're just going to go for it. So these are the second part of our notes. We're not going to add and subtract at this point. I'm going to leave it on there. I may add a little extra video for those of you who want to know a little bit extra, but for this class this year, we're only testing on multiplying and dividing because it's easier. We have to kind of get common denominators here with these, or common exponents. And that's why we're not going to quite deal with that. So we're going to zoom in here and we're going to focus on these. So what happens is you could write this out into standard notation. So 3.1 times 10 to the third, you could write it out as, what is that? 1, 2, 3, that'd be 3,100 times. And you could write this out 4, scooch it over 5 decimal places, what is it? 470,000. And then multiply those with lots of digits. You can always do that. So if you're a map testing, that is perfectly acceptable. But here's a little way to do it a little bit quicker. So what we're doing in this first step is noticing that it's a multiplication problem. So that's what we're going to write. It's a multiplication problem. That's what we notice. So what's happening? It's a multiplication problem. How do we know that? Well, the parentheses are right next to each other. Okay, cool. So there's our multiplication problem. Next, we're going to notice that we're going to group the coefficients and group base tens. Now, what do you mean by coefficients and base tens? Well, look at what happened. Look at what happened. I'm going to kind of go with almost a highlight here with our drawing utensil. That if you look, see, this is the coefficient right here, and this is the coefficient. We just grouped those together. And notice what operation is between? Yes, you're right, multiplication. Okay, and then we grouped, let's highlight the coefficients too. Okay, so we did that. And then we're going to group our base tens. Okay, this and this. We just put those together. Now, do you have to rewrite this step? No, because at some point you're going to be able to go from this step all the way down to here. But these are our notes. We got to get to what we're doing and why we're doing it. Okay, so we did put those together. Now, what do we do with those coefficients? We multiply just like we normally would. And then, okay, over here to the right, here's where the exponents come in handy. We have 10 to the third plus 10 to the fifth. Since we're multiplying our bases, what do we do with our exponents? To get 8, we add them. Remember those exponent rules. So it kind of goes a little bit quicker. Then multiplying it out to like 3,100 times 470,000. So from here, we multiplied the coefficients, kept the base, so keep the base, add exponents. What base did we keep? The 10. Remember the 10, the 10, the 10. So we multiplied the coefficients, kept our base, added the exponents. That's what we did. Now from here, this is kind of a little making it beautiful. So then from here we adjust the coefficient to be between 1 and 10 and add 1 power to the exponent. So basically here, this is technically not scientific notation because we just need one non-zero digit and that decimal is not in the right spot. So what we did was we just kind of scooched it over one, and I don't have the pen, so I showed this highlighter. So that's why our decimal is now in this spot. So we just scooched that over one. If we moved it over one towards our positives, we needed to add one more to our exponents. All right, so that's pretty much what happens with multiplication. Same thing happens with division. So this is a division problem. We're still going to group. Oh, I didn't highlight the group base tens. Group base 10. There, now it matches. Okay, cool. But we're going to do the same thing. So we're still going to group coefficients and group base tens. That's still going to happen. So we group our coefficients, this 7.5 and this 2.5. But notice, because it's a division problem, it's still division between those coefficients. Okay, so we grouped the coefficients, and then we're going to group our base tens. We have 10 to the 6th power and 10 to the 4th power, which means we have 10 to the 6th divided by 10 to the 4th. Now, normally when we have this, what we do is that's the same as saying 10 to the 6th divided by 10 to the 4th. We know what to do when we divide with exponents. That's in our rules. So keep those rules in mind from our other lesson. So we can divide 7.5 divided by 2.5 gives us a beautiful solid 3. Look at that beautiful whole number. And then from here we keep our bases 10 and our exponent 6 minus 4 is 2. So what did we do? We divided coefficients. Keep base, subtract exponents. And make sure to spell exponents correctly. Ta-da! All right, awesome.